lecture discusses collisions in 2 dimensions. And if you look at this picture, you see a red ball and a blue ball coming together and colliding. And so this is the initial velocities and masses, and coming at a 50-degree angle to the y-axis. The balls coming like the x-axis, and they collide, and they go off in these different directions. So we're going to look at the idea of conservation of momentum in 2 dimensions. And we have to break up the xy components, or break up each of these velocities into the xy components, so that we can solve for the conservation of momentum in the x direction and the conservation of momentum in the y direction. So, with the x component, they set this up so they have final momentum in the x equals initial momentum in the x, and that's why you see m1 v final 1x plus m2 v final 2x equals m1 v initial x plus m2 v initial 2x. So what you're doing here is this v1 final x is this component right along this line, and the v final in the y direction is this component along this line, and that's what we're going to look at next. Is the y components. It's the exact same thing. We're just looking at the velocities in the y direction. So here we go. We're going to look at the x component, and the final x component is here. That's the m1 v final 1 in the x. And here, the x component is the m2 v final 2 in the x. The initial velocity in the x is here. And the initial velocity in the x with the 1 is here. Okay? So we're going to go ahead and plug those numbers in. We have m1 v final 1x plus m2 v final 2. See, this is 7 meters per second down here, and it's the cosine of 35 to get that x component, so that's why it's 0.7 meters per second times cosine of 35 equals, initially, it's 0.15 kilograms, 0.9 meters per second, and it's the sine of 50 because it's this component right here. Sine of 50 is the opposite of the 50 degrees, so it's the sine of 50 there. 0.26 kilograms is down here, and it is going 0.54 meters per second in the x direction, so you don't have to do sine or cosine. That's just it. So you only have one unknown, so you can now solve for v final 1 in the x. Just go ahead and do the mathematics, and you can solve for v final 1. The next thing we look at is the y component. It's the exact same thing, but in the y direction. So we go ahead and plug in our values, and this is the y component here. We have 0.15 kilograms of v final 1 in the y direction. Here's our 0.26 kilograms. Our component is in the negative direction right here, in the y direction. We do sine of 35. Here's 35 degrees. The opposite side is this component right here, times 0.7 meters per second. And we have the negative sign because it's going down, equals 0.15 kilograms. We have this component right here. That's why they use cosine of 50 times our 0.9 meters per second. You'll see a negative sign right there because it's pointing down. And the mass was 0.15 kilograms. The blue ball, the second ball, has no component in the y direction, so that's why we have 0 right here. The x value that you ended up with should have been 0.63 meters per second. The y value is 0.12 meters per second if you solve for the v final of y. And then you have to do the Pythagorean theorem to find out what the actual resultant, the final resultant is, 0.64 meters per second. You can also find the angle by doing an inverse tangent and coming out 11 degrees. So this resultant velocity we ended up with was at 0.63 meters per second in the x direction, 0.12 meters per second in the y direction, and you can find that angle right there doing inverse tangent. Here's a problem I would like you to do. You can pause the video and try this on your own. It's a two-dimensional explosion. A firecracker is placed inside a coconut of mass m. Initially at rest on a frictionless floor. Blows the coconut into 3 pieces that slide across the floor. An overhead view as shown in figure 9-13A is what we see here. Piece C with a mass of 0.3 m has a final speed of 5 meters per second. What is the speed of piece B with a mass of 0.2 m? And what is the speed of piece A? we can figure out that since the coconut has a total mass of m, the mass of piece A must be 0.5. So we'll go ahead and use conservation of momentum here. Pause the video though again, like I said, and try this on your own. And also, I want to point out the x-axis is drawn here along this line. The y-axis is drawn here. So they picked these lines here to crooked. They tilted their axis to match it up along a certain velocity. So it'll be nice in terms of this. We know that V final A has no momentum in the y direction. So go ahead, set up conservation of momentum in the x direction, conservation of momentum in the y direction. I have two unknowns. See if you can solve for your values. The y direction is the most promising because we know the piece A is traveling along the x direction and it has no momentum in the y. So we're going to go ahead and use this initial momentum in the y equals final momentum in the y. And so that you have to, we know the initial momentum in the y, we know that that value is 0. The final momentum in the y is just each piece having a certain momentum in the y direction. And so our initial momentum is 0. The final momentum for A in the y direction, that is 0. Momentum for piece B in the y direction is the 0.2 m, that's the mass, and the velocity is V final for the B, sine of 50 degrees, that's this piece right here. Sine is this component of that velocity. And over here, the y component is sine of 80, so that's this component here. And it's times 0.3 m, 5 meters per second, because that's mass times velocity right here. Solving for V final, we end up with 9.6 meters per second. Okay, continuing on, go ahead and look in the x direction. Do the exact same thing. Plug in our values. And in this case here, we don't have any momentums that are 0. But we do know this 9.64 meters per second now. So you multiply by its component, cosine 50 to get its component. And for the C piece, it's cosine 80 times its velocity to get the component of the velocity times 0.3 m. And if you go ahead and solve for that final velocity in the A direction, you end up with 3 meters per second.